All right, here is a typical AR-T13. This is one that is on display at the Rockwell Collins Museum, and as you can see, the cover is already removed. The first step that one has to do is you'll find a cover here that has a Zeus fastener on each side, the right side and the left side, and a screwdriver or even a quarter down into the slot of the Zeus fasteners and a half a turn should pop right out. So now we have the top cover off. Let's go to the, oh, are you ready? Okay, the cover removed. You can see the components of the AR-T13. Let me just give you a rundown as far as the sequence of tubes and so forth. This tube right over here is the PTO oscillator. It's the oscillator tube. The AR-T13 has an oscillator which is permeability tuned by a slug in a coil, which you'll see later, that has an operating frequency from 1 to 1.5 megahertz. That's it, 1 to 1.5 megahertz. The next tube that follows right here is a 1625 doubler. It's similar to the 807, but it's a 12-volt filament. So you have a doubler tube here that will double the frequency. Well, when I say it's a multiplier tube, this tube can either double, triple, or quadruple. Then you have a second tube over here, which is a multiplier. That's strictly a tripler tube. So if you take 1.5 megahertz and you go through a quadrupler and a tripler, you wind up with 18 megahertz. The operating range of the AR-T13 is 2 to 18.1 megahertz. Back in these days, it was called megacycles. So you see MC in a lot of the documentation. Following the last multiplier, you have the power amplifier tube, which is an 813. And the plate cap of the 813 runs through here. And from here on out, this whole section is part of the antenna. It's like an antenna coupler, an antenna tuning system. It consists of coils, like a variable coil down here called a variometer, a large 200 picofarad capacitor, a tapped inductor, and all of these are operated through these last three knobs designated the C, D, and E knobs of the AR-T13. One thing I forgot to mention as far as the variable frequency oscillator, that is tuned by a knob over here called the B knob. That's a multi-turn knob that goes through 20 revolutions. Every of the other knobs are such single turn. The knob next to it over here on the left is the knob for the multipliers, and all that does is switch in various coils and trimmer capacitors. You notice that we can look at this later, but you can see that these segments are just pieces. Like the first one goes from 2 to 2.4 megahertz, etc., etc., etc. Little increments throughout the whole spectrum. Now, we talked about the RF section. We have an audio amplifier here that takes a carbon mic or a dynamic mic. There's a switch underneath the panel that you can flip to either the carbon or the dynamic. I see that this is actually hand wired. There's a little safety wire that's on carbon. Then you have a side tone audio output here that actually it's the level of the audio that you get from the audio amplifier can be set with a control that has 6 positions. In a little bit we'll take this out to show you. The output of the amplifier assembly drives the 2 modulator tubes. There's 2 811 modulator tubes right over here. We'll take a picture from the back side. Here's a modulation transformer. And that's all the audio. Now, the PTO variable oscillator, there's a method of calibrating your frequency, and this is done by what's known as a CFI. It's a crystal frequency unit that has a 200 kilohertz frequency that gets multiplied such that it produces an entire spectrum of birdies throughout the range of 2 to 18.1 megahertz. And there would be a manual that's on the lower tray here that has a tuning procedure for each of the frequencies throughout the entire spectrum. We can show you that later, a particular page of that document, but you'll find certain frequencies in bold. Those frequencies in bold happen to be around a birdie. So you know exactly what your frequency is by going to, well, once again, we'll get into the operation later, but then the front panel control. But there is a way of using a crystal controlled oscillator around the frequency that you're tuning to make sure that you're on that frequency. And basically that's the essence. Of course, the antenna out here is switched through a glass relay. You have a receiver input, just like any old station. You have a relay that switches your antenna to either the transmitter or the receiver. The receiver is a separate unit, like a BC348, and this glass relay in the relaxed position connects a line here called receiver up at the top to the antenna. When the transmitter is keyed, the receiver line is broken and the antenna is now connected to the output of the tune circuit. Right, this point right here is the output of the antenna tuner, the other side of the glass relay. And that's done by a relay here that is designed so that it will take CW keying. You can key at 20 words per minute. And that the audio amplifier and the frequency control unit can be removed. There are 2 Phillips screws on each one that have to be loosened. Which I am doing now. That should remove those 2. You may have to re-edit this. Man, is that?
It's in there tight.
No. Alright.
Okay. Maybe you want to hold it.
I have to rock it just a little bit. Make sure that the screws are completely loose. They may still be engaged. Yeah, I think that one, there, yeah. The reason that didn't come out that clean is because the screws were still engaged to the chassis. That should be, alright, and removing it, after removing the 2 screws on either side and the oscillator tube for clearance, you just have to rock the thing and pivot it backwards. And this will disconnect the connector. You cannot see the connector on the chassis, but in the bottom there's a Jones connector here that's got a 12-pin connector that has to be disconnected from that which is on the chassis. So, and I noticed, you're going to cut this? Somebody took out a tube that had a, this is an octal tube, one of these, probably one of the tube bases, here it is.
Oh, somebody cracked a tube when they put it in there.
There's your tube base. The removal of the CFI unit is very similar. There's 2 Phillips head screws, one on each end of the CFI unit, that have to be removed or disengaged from the chassis. And let's hope this comes out easy. It does. Once again, looking at the bottom of that, there's a connector. This is an 8-pin connector, Jones connector, that connects all the power to that unit. Now, as far as problem areas, of course, there's always the case where a vacuum tube gets weak or a filament opens. These are some of the things that you have to consider. Just by looking at filaments, of course, same thing applies to your 813, which you can see the filament easily, and the 811s, and of course the glow of each of these other vacuum tubes. You cannot detect any tube problems by looking at the tubes, because you've got the standard octal 6V6s, there's a pair of 6V6s and a 6 SJ7 tube. So it would be handy to have a tube tester or have a source. Two of the tubes from the CFI unit, you can see, it has a pair of 6SL7s and a 12SA7, which is a metal tube, so you wouldn't be able to see. I would say that, you know, as far as tubes, it's your usual tubes do get weak over time, and especially in the audio system, if you have any problems with loss of audio, there's several areas of concern. And first is to look at the vacuum tubes in your audio unit, make sure that they're good. The last 6V6 of the audio unit, through a transformer, drives the grids of the modulator tubes directly, so any faults of the audio would be in that area. And so you do have some relays involved within the chassis, because this also supports the CW mode, and audio is disabled when you're in the CW mode, and so you go through various relay contacts, which could all, if you have an older unit, the first thing to do is make sure that your relay contacts are good and they're not tarnished or have resistance when they're closed. There's the other thing as far as maintenance on the RF section, as I had mentioned earlier, from about here on out to the end, you've got the antenna tuning system. You have a variometer. As far as any maintenance on that, you do have some slip rings on that variometer that should be cleaned with contact cleaner periodically. The output capacitor on the other side, this 200 picofarad, it's a big variable capacitor. Not much there, except that it does have another fixed 200 picofarad capacitor. You notice that on this dial, there's two segments. There's a segment that goes from 0 to 100. All right. Just discovered here, this unit has the E dial over here and the D dial reversed. I was making a point about the fact that the variable capacitor over there has got two ranges. Well, that dial is really over here. One of the range goes from 0 to 100, and the other range goes from 100 to 200. What happens there is that during one segment, this 200 picofarad capacitor, ceramic capacitor, is open. There's a little switch on the segment of the variable capacitor over here that closes that switch above the reading on the dial, and I'd have to go back and check whether or not the capacitor is in on the 0 to 100 to 200, or it's in on the 0 to 100. But that's why that has two ranges, and there is a blank segment between the crossover between the two, that the manual and most hams, if they've read the TO, will realize in the operation you have to unkey the transmitter, otherwise you could flash that switch which is opening or closing.
Oh, that's
And
a key point.
That we don't
That's the
want-
kind of thing we need to learn. So,
Yeah, that-
in other words, this dial, which belongs over here, when you tune this dial over here manually, never go through this
unkey it.
crossover grab
Yeah,
with
if
the
you look at
transmitter
your-
key.
Hopefully most amateurs that are putting these things on the air have a copy of the TO or the NavWeps manual.
Yeah.
And if you look at and there's also another manual called the operating manual in the Signal Corps. They make a strong point, caution, unkey transmitter whenever you rotate between the two segments of the dial. During the blank portion, when the index is on the blank portion, make sure that the transmitter is unkeyed. So that's important. We will correct these things before this is finished and pick it up from there. Okay, the unit has been turned around and we have a little plexiglass panel to show you the rear. Normally that's a chassis that has the holes just like this. It wraps right around. So you can see the top side of the ART-13 tube, and over here is the plate coil, choke plate coil, and then the two 811 tubes. You can see the top two terminals of the modulation transformer go to each of the two plate tubes. Basically, and there's the modulation transformer. The primary of the modulation transformer, coming from the audio amplifier way over on this side, is right over here. This is a primary winding, and that's a secondary winding. And you notice that there are 1, 2, 3, 4 terminals in the secondary. All this wiring here, you might wonder what's that all about. Well, in the modulation technique, the left-hand side of the ART-13 is the business end of where all the input-output wires go to for control, and also the antenna. You notice there's 3 plugs here. The central one is the U7B. This is the one that everybody wires up to the dynamotor or to its supply. The U-7 is your power plug for the. Okay, one thing here. The top one here is the receiver. Now this is the connection that goes to the relaxed side of the relay. Whenever the transmitter is keyed, this connection is broken. You also have another connection down here to load coil. This is for some of the load coils that are required that provide a connection between the